everyone. The third session for today is based on duct design for an IT park, and it's going to be presented by Mr. V. Mohammed SIRAJDEEN. Mr. V. Mohammed SIRAJDEEN is working as an HVAC engineer at Innovel Engineering International Private Limited. He has a total of 4 years of experience in the HVAC design firm. In spite of having a festival and coming here and teaching us, thank you so much, sir, and festival wishes to you. Thank you, sir.
Yeah, thank you very much, Vishnu. Such a wonderful introduction. Hope you can hear my voice, right? Voice is
Yes,
audible.
sir, you're audible, sir.
It is clear now.
Yeah,
So
yes, sir.
okay. Can we wait for the audience or let us start? Anthony, sir.
Yes, sir. It is your wish, sir. Even we can have some discussion. If audience, if you are having any doubt regarding that NSDC, they can shoot the questions.
Okay.
We can have some discussions, and meanwhile, when all the participants join, so then we can start our discussions. Participants,
Okay, sir.
any questions regarding NSDC, you can share it in the chat box, or unmute yourself and you can ask till other participant joins. Hello. So any technical clarifications, any discussions is there, you can share. There is a question saying that do VRF need a duct?
Yeah. VRF needed duct.
Yeah. So
VRF chilled water DX system. Even a VRF is nothing but a variable refrigerant flow with single outdoor unit. We have a multiple indoor unit that is called VRF. Even a DX system, there is a much ductable units are there. More than 5 TR, 10 TR, 15 TR, 20 TR capacities with the DX systems are there. Even that is also required ducting systems.
yeah, so I can add to this. Requirement of duct is decided by the type of system. Window split and the small systems, they don't require duct. Okay.
Yes, sir. Yes, sir. Exactly.
And we having a zero static. The systems, okay, which are having high capacity, okay, ceiling suspended and floor mounted systems. Okay, they of course are, it can be a VRF system or it can be a central plant system. Can require it. Okay, so it is not specific to whether it is VRF or chiller. It is specific to the capacity of the system. Okay. So any other question is there also you can ask. Are the softwares available for trial versions, sir?
Yes, there is a software called MacWay Duct Sizer. There is a free software for duct sizing. We no need to pay for that software, or it is not a trial version. It is a full version with free of cost. I have attached the link in our presentation itself. We will see in when the slide is coming.
Okay, yeah. So you can note down the link and you can have for duct design. There is software. I think even for load calculation also some softwares are there. I think a speaker he can throw more light about that. Okay. So there is one more question. Sai Yasmin. Sir, is ductless air conditioning system for possible for a large multinational companies? Ductless system. Is it possible?
So ductless system, it is not possible. If it is possible only for low high ball units, such kind of small unit only. If it is a bigger unit or bigger size of unit, we have to go with the ducting system.
Yeah. So if you have multiple small cubicles like you have in hotels, no. So there we can go for fan coil units. Okay, so fan coil units, you can have multiple fan coil units. But I think if you are having a bigger system, so you have to go for a ducted system only. Okay, maybe some big hall and like that. Okay, so there you have to go for a ducted system. But with the central plants, we have a ductless system also. It is possible if you have a multi-storied hotel, just a cubicle alone. So there you can go for that, I think. Okay. Okay. So software name, I think the speaker he has given in the chat box. Okay. Okay. So any other question also you can just put it there.
So we have a 30 participants till now.
Yes, sir.
So yes, sir.
We can start, sir. We can start your presentation, sir.
Yes, sir. Before getting into the program, can everyone say hi by switch on your video? Is it possible? If you are not okay, then just leave it. If you're okay, come and say just hi, so that it will be you are brisk and you are very interactive. Since it is a afternoon session, everyone will be definitely exhausted. So I feel so. Is it possible? Anyone is ready?
Yeah, I think some of them they can say hi. Okay, so students, you can say hi to the, Mr. SIRAJDEEN.
Hi, sir.
You can switch on your video as well. Okay, I have
Yes,
to switch.
sir.
No, yeah. Yeah, Shaswant. Hi. Good afternoon.
Hi, sir. Good afternoon, sir.
Hey, Shashwant, I appreciate you here. You just came. You have initiated. Please share your mail ID and contact number.
Thank you, sir.
Kishore switched on your video. Say hi. No.
Hi, sir.
Yeah. Good. And then
Hi, sir.
yeah. Hi. Good. Hanurak. Hi.
Hi, sir.
Yeah.
Good afternoon, sir.
Yeah. Good afternoon. So good. So I want to ask you a very important question. That is, it will help for our drive the program to in an effective manner. So I will ask in chat box. So you can also reply in a chat box. So it's kind of poll. Can answer everyone. Good. Good. You can say if you are confused or exhausted, so that we will take it in the take the program in an effective manner. If interested in the morning. Good. Okay. Good. Then another important question. Had your lunch? Had your lunch? You can say yes or no. No, 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 no. Why? Actually, we supposed to have a lunch. Then only we will be in a, we will have a energy to listen, or we will be a very interact. We will be very interactive. So I won't mind if you have a lunch in the session itself. You just listen and have a in another hand. There is not a problem. So, but just listen. That's it. And yes, we will go. So we will start the program. I think 32 participants still now 33. Okay, and I will start the program. Good. Uh, uh, Thanks for the wonderful opportunity to showcase our value and teach the teach share to share our knowledge to students. It is a really wonderful opportunity. I thank Ishri and Co College and the whole team and Ishri students in Ishri team, office barrier, everyone. Thank you, everyone. Today we are going to in this session we are going to talk about how to design a duct system. Okay, uh, in a duct system, um, so this is about me. I'm Sirajudeen. I'm working for a company called Innoval Engineering International Private Limited. This is my contact number and email ID. Please note it down. If you have any queries in future, just feel free to contact me. I won't mind. The table of conduct. Today we are going to talk about these 10 points. Okay, the first point, what is duct and the purpose of duct? Okay, we want to know what is duct. Everyone may not know what is duct, so we should start with a basic question. Then purpose of duct. Okay, the duct will help to what will help, how it will be effective or how it will be useful. So these kind of things and classification of air, what what are the type of airs in the duct traveling, then types of duct fittings, dampers, drills, unit conversion. Okay, then recommended velocities, how much velocity should be in a duct, and then duct sizing, classifications, type of pressure. The based on the pressure, the static pressure will be declared. Then aspect ratio, codes and standards, installation, duct leakages, layout and BOQ. Finally, then we will have a finally on what do not do. So with that we will end the program. So I request everyone to see the picture and say the story. um, it is better if Vishnu or somebody else sharing the screen. Can I stop sharing?
Okay, sir. I'll share the screen, sir.
Yeah, I'm
Vishnu, you are,
stop
I think,
sharing.
with the two devices. Okay, so just have one device alone. Otherwise, echoing will be there. Okay.
Vishnu, are you sharing? Just open and pause that screen and then share. No, 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 no. Just go back. Go back. Yes. Now move the screen. Next, back. Just click one back, one step back.
Sir, this is how I'm able to present it, sir. I don't know.
So
The
the
animation is not
animation is
working
not
for me,
working.
sir. Ah, yes, sir.
Okay. Then not an issue. I will share. Sorry for interruption. So it will be the step by step animation will be effective. So I will share. Not an issue.
Okay, sir.
Okay. So the screen is visible now. Is it visible, right?
Yes, sir.
Okay. Can anyone say if I see the picture and say the story? Can anyone say the story? What is that? uh, regulating airflow, it delivers air. Suspend Kanna, Vishnupriya, good. Any others? Okay, good. Not an issue. The duct is a conduit, or it is it's like a conduit. It is used to pass the air in the heating or heated air or ventilated or conditioned air, that it will just deliver the deliver the remove and air. Ducts or conduits or passage used in heating, ventilation, air conditioning system to deliver or remove the air. The needed airflow includes such as supply air, return air, fresh air, exhaust air. Okay, these kind of there is multiple types of airs are there. So it is needed to include. So okay, ducts are one method of ensuring acceptable indoor air quality as well as thermal comfort. Okay, it is also ducts also play an important role in indoor air quality and thermal comfort. What will happen? Proper air will not deliver to a room. The indoor air quality will not be maintained. Okay, so ducts are main import. It is playing very important role in HVAC system. Then purpose of duct. What is the purpose? Okay, why cannot we give us one audience ask the same question? Can we supply air without duct? Why cannot we supply air in a in a big hall by using single HU? We cannot supply air without duct. The duct purpose of duct is take a air from from the AHU to the receiver. Who is the receiver? The receiver will be a man or a process equipment or data center. That is the receivers. Okay, the purpose of duct is to take the air from the AHU or fan or any equipment from the equipment to the receiver. Okay, the major purpose of duct is to carry the air from one point to other without bringing it in contact with the outside atmosphere. What will happen no if we keep a AHU in an open hall? It will simply the whole air will mix with ambient. So we cannot take a proper air into the or conference room or workspace or a particular space. We cannot take a particular air into the uh, required space, so that we cannot maintain a proper indoor air quality. Okay, uh, so the carrying air may be supply air or return air, fresh air. It can be anything. Okay, though then how to classify the air which is passing through the duct? Okay, we can say the simply using the air duct passing duct is used to pass the air. We are simply saying what kind of airs will be passing through the duct. One is a supply air duct. Okay, what is supply air duct? Conditioned air is supplied to the conditioned space through air terminals. So by using AHUs, ceiling suspended units, fan coil units, in any kind of cooling systems, by using cooling system, delivering the air is called supply air duct. Return air duct, we supply the air into the room. Okay, we cannot take 100% 100% pressure from ambient always, unless otherwise it is required. So if we want to run a machine or it it is like a, if you want to vacuum cleaner, if one side you just or if you one side stop the push-in, the vacuum will not work. Okay, that is what the issue also do. The issue also required one side downstream side suction, and upstream side it will deliver. So it is required to take the return air from the room. Then fresh air. When we supplying the 100% supply air to the room, there will be losses in exfiltration. Okay, it will be like a 10% approximately generally. So that 10% of air, and the fresh air also, the fresh air is calculated based on the area, and based on the persons as per ASHRAE 60.1. There is some recommendations from ASHRAE. Based on that, pressure will be calculated. So that amount of pressure will be bringing to the AHU by using ducts. Then exhaust air duct. Where will be exhaust air duct used? In our case, there is a toilets. Okay, uh, while we are designing for IT building, we should not only focus for the air conditioning. We should focus, we also should focus for ventilation. Okay, what is ventilation? It is not, we want to supply a fresh air to the room, or a toilet, or a process room, or a battery room, or electrical room. Then we need to exhaust how much amount of we are supplying, the same amount of to be exhausted to the ambient. That is called exhaust air duct. Okay, so this kind of ducts are there: supply air duct, return air duct, fresh air duct, um, exhaust air duct. Even some countries they will use makeup air duct instead of fresh air duct. They will use in the Thames. Okay, then types of ducts. What are all the types of ducts available in the market? It is a square duct, rectangular duct, round duct. Okay, then oval, spiral duct. If the aesthetic is very important, no, then client will go, if there is a open ceiling and aesthetic is very important, then client will go with the oval spiral duct. And from the main duct, this is the main duct. Okay, this rectangular duct, spiral, square duct. Assume there is a size of 400 cross 800 size. From that duct to air terminals. Air terminals is called outlet. From the grill, diffusers, those things are called air terminals. From the main duct to air terminals, we have a beam cross section or any space constraint. We need to such a place we have to use flexible ducts. Then round spiral duct. Uh, it is there's a difference between round duct and a round spiral duct. There is no aesthetic requirement, and just they want to uh, use for the requirement. The client will go with the round duct, and some client will use a spiral duct for aesthetic purpose. So in a factory, we are uh, the a factory or any open space, huge space, warehouse, we are using a rectangular duct. In the sense, it will not be a look it will not look good. Some boxes, big boxes are will hanging on ceiling. It will not good, very, it will not look good. So that kind of places we can use a round spiral deck. It will looks good. Then types of fittings. These are the ducts. We need to connect one duct to, if there is a bigger size duct, then say example 1000 cross 500 is a main duct. Then after the branch ducts, the main duct size will be getting reduced. That is 400 cross 800. Right now I'm saying 400 cross 800 is in mm. So everyone, I hope everyone is aware of mm, feet and inches. and basic units. So from bigger size to smaller size, or we need to take off branch, and if there is any beams, so we need to take, or there is any pipes clashing, fire pipe is going, fire or plumbing pipe is going, or there is any electrical cable trace, so that we need to use this offset duct. If there is a small bigger size to smaller size duct conversion, we need to use this concentric tapper or reducer duct. Based on the space availability, there is a beam top there is a beam crossing or pipe crossing, we can use eccentric tapper. Eccentric tapper, we can use a top on a flat on bottom, or a flat on top, so we can rotate as per our requirement or space availability. Then 90-degree elbow, it is a the elbow will be generally designed the center axis, from the center point to in this curve, no, it will be 150 radius. So if you taking a quantity, or if you are going to design a, or in a elbow, you have to design, you have to consider the center arc is 150. Then 45-degree elbow, some cases we cannot use a straight away, we cannot use a 90-degree elbow. That cases we can use two number of 45s, or offset we cannot use this kind of offset, we can use a one elbow here, then we can uh, run a 1 meter or half a meter duct, then we can another 45-degree elbow we can use. So that kind of situation is mainly based on this 45-degree elbow. This is canvas where where we use generally from equipment to duct. Why canvas? Because if canvas is not there, no, uh, the equipment is a vibrating one, fan or HU, anything. If you say anything, any it is a vibrating equipment. So what will happen if we connect that straight away to the HU or fan or any equipment? In the noise will be much, and then in a short time the duct connections getting loose, so there will be there is a case of leakages in duct connections. So from the HU or fan to the duct connections, we definitely we should give a canvas connection. Canvas connection is the black color seems it is a kind of cloth, so it will be flexible, so that the noise will be arrested, and we will avoid the damages in duct connections. Okay, then shoe collar from main branch to main duct to, if you are taking a branch duct on main duct, we have to use these kind of collar pieces. Okay, then only the air will travel in a smooth manner. Then this is a trouser piece. If you want to take off a branch or branch in main duct to multiple places, we have to use these kind of trouser pieces. These trouser pieces can be a three, even can be three, okay, based on the requirement, but that is not recommended. We can use maximum two connections. Then duct materials, what are all the materials are available in the market is MS duct, GE duct, aluminum duct, FRP duct, stainless steel, fabric duct, and PVC duct. MS duct, GE ducts generally will be used in factories when it is a corrosion area, or it is a very it is process requirement. There is any material will affect the duct, GA duct or MS duct. There will we have to go with aluminum duct. Okay, then FRP duct. It is also depends on the process requirement. Then stainless steel. If we design for operation theater, or it will if the conditioned air is passing through GI duct or MS duct, it there's when we are in a operation theater, okay, the conditioned air is passing through a GI duct or MS duct, there's a chance for corroded or contaminated air passing into the patient. So avoid such cases. Operation theater or critical rooms, it is recommended to provide with stainless steel ducts. Fabric duct. Fabric duct, it is nothing but cloth. It is like a cloth. They stitched some cloth in some shape and put it in a linear without any reduction and anything. They will simply run a duct in a linear way. We will talk about in the next slide about fabric duct. Then when the PVC duct. PVC duct is also based on the process requirement, but it is mainly used for return air duct or exhaust air duct from toilets or any stringent places. We cannot pause a steel duct. There we can use PVC ducts. Then these sheets are there, no, it is cut from the roll. Actually the standard duct sheet is available is 1.2 meter width. The maximum length is even in a kilometer by the roll. Okay, we can cut the sheet as per our requirement, but the length of duct is no, it is maximum 1.2 meter only. Generally it is available in market 1.13 meter. Balance will be used for this corner piece and that all. Okay, so this is the standard length, but by width we can go up to maximum 2.4 or more than 2.4 or 5 meter. It will be like a big, like a house. So generally maximum 1.2 is a standard. Then with lengthwise we can go up to 2.4 meter. Then there's a type of dampers. I'm simply running this thing. I just want to know any question has been raised. Okay, no questions. If you have any questions now, as of now, you can ask. Is it understand for you, or if you have any queries, you can ask, or else I will go again. So no questions. I just proceed. Where are the fabric ducts used? It is used in warehouse where the duct cannot be installed. There is less possibilities for installing the ducts. If you want to install a duct in the factory height will be like 10 meter or 8 meter. You just imagine our house is generally 2.4 meter height or maximum 3 meter height. The factory heights are like 10 meter height, 14 meter height. We cannot we cannot use a crane or a scaffolding. Scaffolding is like use a term used in our Tamil term. It's saram katti idu பண்ணுவாங்க இல்லையா, அது மாதிரி like so scaffoldings by using scaffoldings we cannot erect such a big duct in a 8 meter or 12 meter height. So for a easy installation and quick process running, some cases they will use fabric ducts. Hope it is clarified. So I'm moving on with the next slide. Types of dampers. What are the types of dampers available in the HVAC systems? There is a generally used volume control damper, fire damper, solid damper, and VAV. There's there is more number of dampers like a motorized damper, non-detent damper, backdraft damper. if we no there is if we go inside the dampers, it will take 1 hour. So I just want to uh, uh, get you the details of basic dampers. You just browse what are the type of damper available in the market, and what is the purpose of dampers, why if we use a motorized damper what will happen, those kind of things you just surf and get a knowledge more. Okay, volume control damper generally you used on branch ducts or main ducts to control the flow. See what will happen if we uh, dump the entire air in a duct. The duct air will go without any it cannot be measured. So it will be, if you want there is a one common workstation, and there is number of there right side 5 cabins are there, left side 5 cabins are there. We have designed for the particular air quantity for this cabins. Do you think without volume control damper the air will be delivered? No. Even we search for the duct at proper velocity, head loss, or as per design, the without volume control damper, the air will not go as per the measured amount. So if what will happen, some room may receive a more amount of air, some room will receive a less amount of air. If a person, the first room will may receive a more amount of air, what will happen without controlling the air, the room will be getting cooled very short time. So he cannot be sit there for a longer period. What will happen the fifth room, um, the air will not go because the entire air gone in the first room. So avoid that cases, we have to provide volume control dampers on branches and main ducts. Fire damper, if a AHU if we are keeping AHU ceiling suspended unit, or our air conditioning units keeping in a equipment, the equipment room, no, we have to keep in the room as a fire safe zone. Okay, if fire happen in a workstation or a control cabin anywhere, the fire should not come into the equipment room. It should not affect the equipment. When the before entering the fire into the equipment room, we should stop the fire by using this kind of dampers. Okay, when the fire uh, is occur, I will just zoom. You can see some small link here. When uh, when you are you just using a lighter on here, this is called a fusible link. You just use a lighter or any fire is touching at this point. Okay, what will happen, the damper will close automatically by shutting. The link will be cut. Okay, so that's to protect our equipment, we will use fire dampers generally. Then collar dampers. What is collar dampers? It will be available in grill. It is like it is nothing but volume control damper. It will be provided on grill. Okay, to control the volume. Then VAV is a separate one, but since we are talking about IT building, I just bring it in dampers under the dampers topic. What is VAV? There is a variable air volume. Okay, there is a even dampers called variable air volume, constant air volume. There is two type of uh, devices are there. VAV what will do, no, for uh, cabins, when we are supplying a common duct to workstation as well as control room. Okay, we can control by we can control the flow by using VCD. But what will happen, there is, if there is no person in the control room or meeting room, the air will simply go. So avoid that situation, so save the energy, we will provide the VAV. VAV how will work? VAV will work based on the thermostat. What is thermostat? It is nothing but a remote, corded remote. From this VAV will have an actuator with a controller. This is a control box. It will have a small kind of equipment to control or actuate the motor. There is a small size of motor is called actuator. It will open close the damper inside this box. Okay, when there is no nobody inside or no internal load inside the cabin or small workstations, anything, uh, the temperature will go high. So we will have a set point on the thermostat. Okay, if the temperature go high, if it is a 22, we our set point is 22, so our set point is 24, and the room temperature is 22, then the command will go to this actuator. Then what will this VAB do? No, it will shut off the damper or control the damper based on the requirement. This is called VAB. CAV, what will this is same uh, CAV is nothing but VAB, but it will have a logic alternative program in the controller itself. VAB will give a variable air volume to the room. Okay, CAV will give the constant air volume at any cost. That is CAV. Okay, just for information I am saying. Then types of air tunnels available. What are the types of air tunnel? Generally, grill or diffuser is most common terms. But there is other than grills, diffusers. There is a jet nozzles. Okay, linear bore grills, square diffusers, round diffusers are there. Even the diffusers available for floor. Okay, if there is a you may know what is false ceiling, but you should know in server room they will be a false flooring. Okay, how the false ceiling is providing the same kind of availability is providing under the floor. They will rise a floor by using structural rods and supports. So or around 500 to 700 floor will be raised like a false ceiling. That is called false flooring. So by there will be a vacuum space under the false flooring. They will in data center or any electrical control room, for the panels they will use control cable to lay the to lay under the false flooring. Okay, that we have that kind of cases, we will have a more space under the false flooring. So we can utilize the same false flooring for supplying the supplier air by using bottom throw units. Those scenarios duct are not required. We can simply pass the air under the false flooring. Okay, but you will know in detail or some other cases, or you can sub for more details. There is another grill is called another diffuser is called jet drum diffusers for a huge amount of quantity in big factories. You cannot use a simple grill like this kind of small grills. We cannot use a factories for supplying huge amount of air. The AHUs will be like 1 lakh cmh or 100 TR, 150 TR AHUs are available in the market for factories. So that cases, the air will be huge. Those kind of scenarios we cannot use these kind of small grills and at all. So that cases we can use jet drum diffusers and at all. This is a grill section. How it will be look in front view. It will be look like it is a wire mesh or a small grill. If we are seeing in a side view or section, this is called collar damper. It will use to regulate the flow. Okay, then the section of diffuser, we can this is a rod. It is nothing but rod. We can by we adjusting this rod, by we can regulate this arrangement. So we can without a collar damper, we can regulate the flow by using diffusers. Then we have seen these air terminals for square duct or rigid ducts. What is it? You can ask me, is it say the same is applicable for fabric duct? No, fabric duct is different. The duct itself, fabric duct manufacturer will provide the nozzles or air terminals. When they are providing, that itself come with the air terminals. Like in the first case, they will give a linear vent, like a small vent on the uh, fabric duct, or porous material, like it will, the cloth itself have some pores, so from that porous air will supply to the room. Okay, then the cloth itself, they will give a small kind of arrangement with nozzles to supply the air into the room. Okay, for a fabric duct, there is no dedicated um, air tunnels like kind of rigid ducts. It is come along with the fabric duct itself. Then units and symbols. Okay, you should know the difference between SI units and IP units. It is very important. Okay, why we know, in the sense, actually we Indian people design a drawing or design do a hit to calculation or anything, we do in a SI, System International. Okay, System International unit. If we go abroad, like Bangladesh or some other country, they will use IP unit. Okay, that is feet and inches. Also, generally, local architect will use in a feet and inches format only. But it is a good practice use, adapted or using in a system SI unit. So request everyone to focus on both unit, but give a more priority for SI units. Okay. Then Q. What is Q is equal to A into V. What is Q? Q is equal to nothing but flow rate. Okay, we are supplying the some. We are saying no. This is a 10 TR AHU capacity with 4,000 CFM. Okay, we are saying CFM or CMH or liter per second. It can be anything. We are saying it is a unit. That's it. We are calling one object by using a name. Okay, there will be a first name, second name, or nickname, so that kind of thing is called unit. Okay, but person is person, that is called flow rate. The flow rate have multiple names based on the units. Mm, if we see Q, the flow rate is equal to arrived based on area into velocity. Hope everyone have covered with the fluid dynamics, sorry, fluid mechanics or thermodynamics, DDJP. Okay, so everyone aware of this. Just I want to cover because it is very important for our today's topic. Okay, then area A. What is A? A is a cross-sectional area of the duct. V, velocity of the air. Okay, velocity can be in meter per second or feet per minute based on the unit, and pressure based on Pascal per meter or kg or mm of water column. In if we go with the IP unit, it will be called in inches of water column per 100 feet of duct. Okay, it is you have to note this point. It is for 100 feet of duct, but we will have a length of 5 feet length or 10 feet length. Okay, in that case, how we can arrive the values for the pressure drop or anything. So we need to, if we arrive a value for some amount of air, we have to divide it for the 100 feet. Then we have to multiply for 5 feet or 10 feet based on our requirement. Or in SI unit, it is very simple and clear. It is available. The pressure is Pascal per meter only, per meter. So you can simply put a length in a meter, or 0.5 meter, or 1.5 meter, or 2 meter. It is a easy way. That is the reason everyone is insisting to use a SI unit for a better calculation, better understanding, easy understanding. If you are familiar with SI, then it is easy to flexible with IP also. Then I just want to highlight some common unit conversions. It may be for silly for some persons. It may be a big thing for some persons. It is based on the perceptions. But if you know these kind of basic things, if you are very strong in these basic things, then you will grow in a very short time period. Uh, then if we split up 1 meter length scale or a rod into feet, there will be a 3.28. That is also like a 3 part of segment will be there. That is 1 meter is equal to 3.28 feet. 1 feet is equal to how much meter? So it will be reverse. It is a basic calculation. You just have to understand everything. Even the what I am saying is will be a very basic, but it is only going to use for your duct design calculation and all. So just note it down, or take a screenshot or anything. Okay, be clear on this. It definitely it is only going to use for your detailed engineering calculation and all. 1 feet is equal to 12 inch, 1 feet is equal to 305 mm, to 1 inch is equal to 25 mm, 25.4 mm. You may wonder, this kind of question will be asked in interview also. The time so many students struggle to answer for these basic questions. So uh, it will be it will be very good if you are very strong in very basic questions. 1 meter per second is equal to 196.85 feet per minute fpm. It is nothing but fpm. 1 hour is equal to 60 minutes. 1 hour is equal to 3600 second. 1 minute is equal to 1 by 60 hours. So the reverse calculation. 1 cubic meter, that is 1 cubic meter is cubic. The how much amount of liter can be occupied in 1 cubic meter? 1,000 liters can be occupied in the 1 cubic meter. Okay, this is a basic things we know in a first standard itself. So we have to apply our engineering from the our from first standard, second standard itself. It is available. Everything has to be applicable in our engineering. 1 liter is equal to, so reverse calculation. So I just want to give us some activity. 1 CFM is equal to other, that is 1 cubic feet per minute is equal to 1.7 cubic meter per hour. Okay, how it is arrived? Can anyone do the calculation in a very in a minute? Is it possible? Can anyone do a calculation in a minute? How it is arrived? We have to do a calculation in a. We have to convert the unit. Cubic feet to cubic meter. We have to convert, then meter to hour. We have to convert. Based on that calculation, we will arrive at 1.7. Is it? Can anyone do? Can anybody do in a minute? I can wait, or I just go again. Okay, I just go again. Feet cube per minute. If we convert the feet cube into meter, what is 1 feet is equal to 0.305 meter. Okay, then the 0.305 into 0.305 into 0.305 will become some value. Then that value into that 1 minute is equal to 1 by 60 hour. Okay, 1 hour is equal to 60 minutes. So reverse calculation. So this 60 will go up. The final answer will become a 1.7. Okay, so you can ask why this why I want to know these kind of conversions. It will be somewhere maybe we have used, we will sometimes we'll say capacity of AHU 1000 CFM, or somewhere we will say 1500 CMH. Okay, sometime that time we have to know these kind of conversion factors for better calculation, better for our knowledge. Then only we can answer for the client questions, attend the client meeting, and we will respond immediately for the client answers. Because they will answer, they will talk in CFM or CMH. We have to specify, we have to talk only the word. It is airflow. Okay, flow rate, we have to use the technical term flow rate. We should not use a word in a CFM, or what is the CFM you are providing. If you are asking a AHU vendor what is the CFM you are providing, it is a very poor question. We cannot ask such kind of question. We have to ask professionally, in the sense we have to ask how much amount of air quantity you are providing for per TR in your AHU. Your opponent, your competitor is giving better than you. He is giving 50 CFM more than you okay. So how much amount of air quantity you are providing for better efficiency? Those kind of questions we have to ask. Then recommended duct velocities as per ASHRAE. There is as per ASHRAE guidelines, as a ASHRAE standard, there is recommendations for designing duct systems. Okay, since we are going to design for IT building, there is a recommendations for main ducts and branch ducts. If it is a main duct, main supply duct, the velocity should be 7 meter per second. It is not more than 7 meter per second. And return air duct, we have to take a return air duct from the room to the HU room. That is designed based on the 6 meter per second velocity. Then branch ducts. Okay, main duct velocity can be much higher, but the branch duct velocity should be lesser than the main duct. Okay, then only the air will go in a smooth manner, and without any, it will not create much noise. Okay, if you see the industry velocity is very high, 13 noise factor generating main ducts 13, and generally supply air duct maximum we can go up to 15 meter per second. Why? If we design say 15 meter per second in a residential building, what will happen? Can anybody answer? For residents, we will design a high velocity duct. What will happen? Can anybody have an idea? You can say in a simple term or a very simple word, whatever you have understood. If we design a duct with high velocity for a house or a hotel or office cabins, what will happen? Yes, exactly, more noise. Isaac, please keep be silent. You are an industrial person. So the noise will be more. So avoid such kind of situation. It is classified based on the areas. Apartments, private office, it is the private office, director rooms, libraries, classified. It can be so it can be allowed for 60 pascals. For achieving 60 pascals or 60 pascal noise level, we can go with up to maximum of 7. It is maximum of 7, but better if we can provide less than 7 is a good system. Okay, then the pressure drop will be less. The fan energy, we can save the fan energy. Okay, the such kind of things we can be designed only based on the area classifications. So area classification is very important. If we see the Israel handbook, they are given in a feet per minute, FPM, that is IP unit. But I'm going to teach the whole system in a SI unit, so I have converted this table into SI unit. So better everyone can take a screenshot or take a note of this. It will be better for you. I'm giving you 5 seconds to take a screenshot or for noting. So I'm moving on with the next slide. That is a duct sizing method. uh, till now we have seen what are the types of ducts and types of air tunnels, what are the things available. We have seen those things. Now we are going to see how we are going to design a, or how we are going to size the ducts. There is a three methods. One is called velocity reduction, another one is equal friction, another one is static regain. Okay, in market generally velocity reduction and static regain, it is not used in our day-to-day practice. It is a very complicated even for us. Okay, but it will be a static regain method will be energy efficient for duct system, but it is very complicated. We have to spend for a day, instead of 1 hour we have to spend for a day. So we will, we will lose our man hours. So it is complicated. So avoid such kind of situation, we will go with the equal friction method. Okay, what is the velocity reduction method? The AHU generally, AHU outlet will be 12 meter per second. Okay, 12 meter per second is like 2300 fpm. If such high amount of such high velocity is passing inside the duct at initial, okay, we have to reduce the duct velocity by as per ISRAE recommendations. Okay, so if you are seeing office space, the main duct main supplier duct recommended velocity is 7 meter per second. Okay, so we need to design for select for 7 meter per second velocity. Then the duct is traveling. If it, in the starting point we have designed for 7 meter per second velocity, the outlet of AHU is 12 meter per second velocity, then the starting duct we have to design for 7 meter per second velocity. Then what will happen? No, there will be a there will be first piece of reducer. After the canvas piece, there will be reducer for smaller size to higher size. If we are the velocity is high, the duct size will be less based on the area, cross sectional area and flow rate. Okay, then we are selecting the duct starting point for 7 meter per second velocity, designing a starting point for 7 meter per second velocity. Okay, if you assume that duct is traveling for 10 meter. Okay, what is velocity? Velocity is nothing but we have seen in a previous slide, that is distance by time. Okay, that if velocity reduction method, if duct is traveling for a 10 meter with 7 meter per second velocity, okay, you just assume that or note it down. Okay, velocity is 7 is equal to distance is 10 meter by speed, time. Okay, we don't know the time. Okay, it can be mentioned in second. Okay, then at the 10 meter end of the 10 meter, we will came to know, if you are doing reverse calculation, take a section on the left side and bring the velocity by length. 10 by 7 is equal to, we are getting around just a minute, I am using calculator. 10 divided by 7, if we get a 1.42. Okay, so velocity reduction method, we came to know that the time the air is reached the 10th meter point, it takes 1.42 seconds to deliver at the end point. Now we know the time. Again, we have to calculate for the next branch. Now we have the time, so we know the we know the velocity and time. Based on that, again we will the velocity will be getting reduced. So it is like a complicated. If we do like this such kind of work in a day, it will take a 2 days. If static gain regain take a 1 day, it will take a 2 days to complete the work. So generally what we'll do, we will go with the equal friction method. What will we do with the equal friction method? We will fix as per there is a recommendation from ASHRAE. Duct friction loss is in between 0.65 pascal per minute to 0.816 pascal per minute. Okay, the maximum limit for factory sectors or smoke exhaust that or any such kind of process exhaust that we can go up to with a maximum of 0.98 pascal per minute. Okay, uh, I will explain in coming point for how equal friction is designed. Static regain. Static regain, we have to maintain velocity pressure at every point. If you are using a, if you are considering 250 pascal at starting point of the duct, okay, you assume that there is a main duct and 5 branches on right side, 5 branches on left side, the tail end of the right side fifth room. That point also you have to maintain a 250 pascal. Okay, if you are maintaining a same pressure at tail end from the head to tail end, what will happen? The duct size will be lesser compared with the equal friction method. So what we can do, we can save the ducts cost, initial installation cost, and and, supplying cost, section cost, everything. But what will happen, no, if you are increasing the pressure, the amount will be added in the fan. So we will not use the velocity reduction method and the static regain method. Generally we will go with the equal friction method. For equal friction method, if suppose we are going to design for a 1000 liter per second flow rate, the flow rate is called in cubic meter per hour, cubic meter per second, liter per second, or cubic feet per minute. There is the multiple units are there. Okay, we can, by using this MacWay software, we can calculate in a IP unit or a SI unit. If we are using in IP unit, there will be a CFM, inches of water column, feet per minute, and equivalent duct size in feet and inches. So to avoid such conflicts, I'm going with the SI method. Okay, SI system international method, in which we are going to supply 1000 liter per second, okay, in a duct with a velocity of 7 meter per second. Okay, the 7 meter per second is as per recommendation by SRA for office rooms. Okay, the head loss is getting increased 1.3 pascal per minute. But what is if you are seeing a equal friction method, there is a recommendation for only in between 0.6 to 0.8 pascal per minute. So if we are going with the 7 meter per second, the velocity head loss will be increased. So what we can do now, in such cases, we can use 0.8 pascal per minute. We can put a 0.8 pascal per minute and select. We have to choose one size of the duct, either width or height. I choose I have considered the height 350, and we generally the height should be less, width can be a more. Then will be in the pattern will be a correct, and space management, the aesthetic, everything will be good. So in this tool, what we are doing, we just entering the flow rate, and we just first we entered the velocity. For the 7 meter per second velocity, head loss is increased, though then we clear all the values again. We entered the 1000 liter per second and entered the 0.8 pascal per minute. Then velocity, the velocity is getting reduced. If we go with the 7 meter per second velocity, the head loss is increased. So since it is increased, though again we are gone with the equal friction method of 0.8 pascal per minute, the velocity is getting reduced. Okay, so velocity is also not a matter. The head loss is also a matter. If maintain 7 meter per second in duct, what will happen? The pressure drop will be increased. Okay, we have to we have to provide a 300 pascal HU instead of 250 pascal. We can save a huge energy in even a 50 pascal. Okay, so our goal is not only a size of duct, we have to save energy. Our only aim is save the energy. That the way we have to design a system. Okay, so always we have to keep in mind while designing a duct system. Hope everyone is clear with this equal friction method. Just to forget about velocity reduction and the static regain. Just for knowledge, know this sizing method. But generally, we are sizing the duct by only equal friction method. Okay, in this method, ducts are sized for a constant pressure loss per unit length. Okay, constant pressure loss per unit length, Pascal per meter. Okay, that's what written in the document. I have conveyed the same. So you can raise your queries if you have anything on that. The time is less, so I have to push more. If you have any queries, just highlight. Hope it is a calculation. Since it is like a calculation, everyone is confused. Seems. At least say I'm not confused. I'm clear. Can somebody say I'm clear or I'm understand? Can somebody say? If you are not clear with this, means I have to start with the first
Yes, sir.
presentation.
It's clear.
Okay. Just so I'm moving on with the next slide. Then plenum design. When we are why we have to give a plenum on the HU or ceiling suspended unit? Why we have to provide? Because the initial velocity will be high. The outlet of HU is designed for a 12 meter per second velocity, or generally they will design for a 12 meter per second velocity. Okay, if the 12 meter per second velocity is entering into our small size of duct, that is 7 meter per, we have designed for 7 meter per second velocity. So okay, the air will go like the air will collapse and sound will be created. Then more amount of pressure drop will be created. So avoid such cases. Generally, we will provide a plenum on a ceiling suspended unit or a HU or a fan coil unit. Anything fan coil unit may not be required, or a HU or ceiling suspended high capacity unit will be recommended to provide with a plenum. Okay, how we can design a plenum? Plenum is generally designed for a 4 meter per second velocity. Our supply air duct system, supply air duct, return air duct only designed for 7 meter per second or 6 meter per second. But in a plenum, we have to design for a less velocity, that is 4 meter per second. Okay, it is for the same duct size or MacWay software. You can, by using the same software, you can design the plenum. And the length of plenum, this is a side view. Okay, imagine this is a ceiling suspended unit or kind of HU or AC unit. Okay, the length of plenum should be 2.5 times of the blow air. Okay, blow air in the sense that there will be a fan. The fan will have a dia, or the cross sectional area of the length of width length of the HU you should see. From that height, from this height to into 2.5 times, you have to consider the width or depth of the plenum. For width height, you have to same like use a 4 meter per second velocity. You just need to put a 4 meter second you have to enter the value of flow rate, and you want to enter the velocity, and you want to mention the height. You have to you have to choose either height or width. Then only we will get other value. The size of that size will be completed. The same way you have to design. Then types of airflow. We have talked on we talk about the air pattern on downstream of the AHU or fan coil unit. If we have not considered any plenum and just we simply install the duct in HE mouth, what will happen? The air will go like mixed pattern. Okay, it is like a turbulent flow. Okay, what if turbulent flow means the noise will be more and air will not be delivered properly. So avoid such cases. uh, our HVAC system fully based on laminar flow. The air should be go in a smooth pattern. It should not go like water. Water can go in a turbulent flow in a chiller or a, we have to make in chiller such cases we have to heat and efficiency. We need to maintain a flow in a turbulent, but in a air side we have to maintain a flow in a laminar flow only. Okay, so that is the reason we are providing a plenum in AHU outlet. That classification system. Okay, there is a two classification system. Velocity, it is classified based on the velocity and pressure. Okay, there is a under the velocity there is a two system: low velocity, high velocity. What is called a low velocity? The less than 12 point meter per second is called low velocity ducts. The more than 13 or 12.7 meter per second is called high velocity duct systems. Okay, then how we can classify the pressures based on the pressure? Class 1, class 2, class 3, low, medium, high pressures. Class 1, there is up to 1000 pascal is called low pressure. From the 1000 pascals to 1700 pascal, it is called medium pressure, and above the 1700 pascal duct, it is a rare case actually. 1000 to 1700 is and my fan is in the fifth or sixth floor roof, and I need to exhaust air from the basement. Okay, that cases the air have to travel for a 5 floor. So you need to consider the vertical height pro by using rho g delta h. Okay, rho the density, g acceleration gravity, and height. So that pressure up, that's it will be like it around based on the height increasing, the height, the pressure up will be straight away added into the fan pressure. So such cases will be such cases, those kind of duct calls medium pressure ducts. Okay, high pressure duct will be in worst case. Generally we will design for a low pressure and medium pressure ducts, and low velocity ducts are in uh, up to the hotel or a residential building, the factories and at all using for high velocity ducting systems. Then types of pressure. Okay, static pressure, velocity pressure. The total pressure is called a combination of static pressure and velocity pressure. What is static pressure? If we measure a pressure by using manometer on a duct path, okay, uh, not in the air path, we are just using the manometer, YouTube manometer. We will be used in fluid dynamics, fluid mechanics laboratory. Hope everyone have aware of this YouTube manometer. By using a YouTube manometer, when the air is traveling through this duct, the air will go on this way. By using this, we can measure a static pressure. Okay, we will say we will design a HU for a 200 or 500 static pressure. How we can measure? By using this kind of measurements, we can measure the static pressure. Okay, it is in it can be a positive or negative. If you are measuring on a downstream, actually what is called a downstream, upstream is entering point and downstream is leaving point. If you are measuring in a downstream, it is called positive static pressure. If you are measuring in a upstream, what will happen? In this case, air will go in this way. Okay, so the pressure is created here, so the pattern is looks like this. If it is in downstream, what will happen? The pattern will be reversed. It will be a suction. Okay, so that is called negative static pressure, positive pressure static pressure. Okay, then velocity static pressure. Velocity static pressure is measured against the direction of airflow. Okay, if a air is going through this duct, we are going to measure against the air. That is called velocity pressure. The combination of static pressure and velocity pressure is called total pressure. But for duct design, we are not. It is not will be useful for you. But when it will be useful, when we are going to calculate for external static pressure, we have to calculate for external static pressure. That cases we have to know about the static pressure and velocity pressure. Okay. Then recommended outlet velocity. What is recommended outlet velocity by ISRE, suggested in the ISRE handbook? They have, since it is a snippet short, I cannot due to short time period I cannot convert it into a meter per second. Yeah, it will be better if I'm converted into meter per second. But you just also know, you have to know, convert the FEM into meter per second. We already seen 1 meter per second is equal to um, the 1 divided by 196.85 FEM. So we will get the value. If it is a 500 FEM, 500 divided by 196.85, we will get a 2.54 meter per second. So like that, generally the velocity, the outlet, what is the outlet velocity? It is nothing but the air terminal velocity. Okay, if you are selecting a grill or a diffuser or jet nozzle, anything, it can be designed based on this criteria. Okay, you also know this slide also, it will be useful for you while when you are designing. Okay, you there is a number of standards and softwares available in the market for designing a ducting system. But if we cannot go in such way, so that if we clearly understand this session, you no need to refer any standards or anything. You just simply, you can do a work, even you can start a work based on this calculation if you are clear with this session. Okay, so be clear with this in session. It will be really good for you when you are designing your calculation, duct design and all. Then selection of grills and diffusers. It is a basic calculation formula. Q is equal to we know in a liter per second or meter cube per hour. Okay, we need to convert into a meter cube per second, because velocity is meter per second. We want the area in meter square meter. If we have a value in meter cube per second, then the meter per second will go in reverse here. So second will be cancelled, then meter 1 meter will cancel. So area is equal to, we will get in square meter. Okay, but we cannot describe a grill in a meter. If we, the grill generally will not be available in a meter. Generally, the maximum available size, maximum is 1 meter. That is 1000 mm. So you need to convert the this formula. This is applied. How we can see how I can apply it. There is a 170 cmh area into recommended outlet velocity is 2.54 meter per second. Okay, then I have converted the cmh into cms, cubic meter per hour, into cubic meter per second, divided by 3600. I got this value. Okay, then I convert the square meter into square, and I take a square root of the value. I got a 136 So I can, but if the value may be a 121 or a 130 or 145. Okay, we have to round off those values. So I round off the value. 135 is into 150 cross 150. But you can do it in a rectangular shape, like you can select a 100 cross 200 size. Okay, that is a different scenarios. So in such a if you divide the value by 18,591 divided by 100, if you are using 100, means you will get some values. Okay, if you are divided by 100, in the sense we will get 185 something. So such a way that you have to design based on the velocity. Then aspect ratios. What is aspect ratio? Longer side divided by short side, width divided by height. That is called aspect ratio. The aspect ratio, the best aspect ratio is 1:1. That is called a square duct or a round duct. Okay. In a worst case, maximum permissible aspect ratio is 1:4. That is, height should be 1 time. The width should be not more than 4 times of height. That is called 1:4 ratio. Okay. Then codes and standards available in the market is ISRE handbook, of course, and ISRE fundamentals. There's a fundamentals, like yearly fundamentals updates in 2005, 2009, 2017, 2015. Even in ISRE we have an updated version of 2017. The earlier version of 2014 we have, the 1999 version we have. So based on that criteria, we have designed duct systems. Also SMACNA standards available. Then duct installations. Duct installation is classified into thermal installation, acoustic installation. If you are going with the installation for wall, that is acoustic installation. If it is a roof installation, that is called thermal installation. Density for acoustic installation, 180 kg per cubic meter. That is 1 cubic meter. If you're taking a 1 cubic meter of cut section, that weight should be 180 kg or 360 kg. What will happen? The kg will increase. The density is also increased. That is called this is a ratio mentioned here. Okay. Thermal insulation density, generally it will be a less. Okay. These are the standards available in the market. Take a screenshot. It will be useful for you. And why we need to provide a acoustic duct and thermal duct? Acoustic insulation is a open cell. It is called open cell insulations. Okay. If you are see in this is a fiber cloth or such fiber cloth or wool. Okay, these will be a open cell insulations. What will do? It will absorb the sound. There will be a number of pores on the pores will be like huge. Okay, it is like a coconut shell and that shells, that kind of thing. It will absorb the noise. Okay. By using this acoustic insulation, we can reduce the noise. If we are designed for 7 meters per second, still we are crossing the noise level is more than 60 pascal. So we have to provide with the acoustic insulations. Well, the same is applicable for wall. For equipment room, the H room is nearby the workstation or cabin. Okay, the noise will be more. So we observe the noise. We have to provide the acoustic installations on the AC rooms. Okay. The acoustic installation recommended for maximum 3 meters from the AC outlet. More than that, the noise will not be traveled. Okay. The maximum noise is traveled till 3 meters. So generally, it will be recommended for 3 meters. The acoustic, again, you have to clear with that. Acoustic installation is only absorb the noise. Then what is thermal insulation? Thermal insulation, if we are supplying a 21 degrees Celsius supply air into the room, what will happen without insulation? The heat, the overall heat will be added into the duct. The duct is crossing one unconditioned room and the delivering into the conditioned room. What will happen? The unconditioned room entire heat will be added into the duct. So avoid such cases. We will provide a thermal insulation for duct to avoid heat gains. Duct leakages. What is duct leakages? If a duct passing through a plenum, false ceiling or without false ceiling, anything. If it is duct is leakages, if you start leakage, it will not be effective. So we cannot maintain a better indoor air quality. We cannot achieve thermal comfort. We cannot achieve it will not be. It will not be a matter what we have focused for. So we have to our job is not completed just completing the design. We have to be clear with the duct leakages after the erection. Okay, we can identify the duct leakages by such big kind of focus lights if you are using this focus lights, we are passing the lights on the deck, we can like a sun said, we can get the emittance from the leakages. By that by that way we can identify the leakages and arrest the leakages. Then we can see in a cultural in a dice stage, there will be a creating a smoke by a small equipment. By using that equipment, we can do a smoke test. We can pass a smoke into the duct, so that wherever the leakages are there, the smoke will be emitted on that leakage. By that way we can arrest. Another is pressure test. These kind of light test or smoke test used for a small building or a small residential building, small low velocity ducts. If it is high velocity duct, what will happen? High velocity duct, uh, the duct will go for a long about a 200 maximum of 200-meter the duct will travel. Such cases we cannot just pass a light or smoke to the ducts for such a long distance. Such cases we have to use this pressure testing. This is the dedicated pressure testing machine. It will continuously flow pass the air through this flexible connection. We have to we can, I will just zoom the any air tunnel point or end cap dummy or end position, we can create such a small hole and connect this flexible connection and build the pressure by using a continuous flow. If you are keep blowing the balloon, it will blast. No, the same like that, it will not blast here, but we will set some set points here, like 60 pascal, we will 60 or 100 pascal, we will set a set point on this, we will set a point on this machine. Okay, uh, if 60 is achieved and there is no oscillation on the digital meter or measuring meter, okay, then we can say there is no leakages and the air is keep on going. There is no flexible, there is no oscillation, keep on oscillation on the 60 to 50 or 60 or 70, again getting 70, then getting dropped down into 60. So there is a leakages, so we have to identify the spots. Now we have identified the leakages by using this method. Then how we can arrest the leakages? By using a silicon sealant. Okay, it is generally it is used in a wall, window, more places it is used. So this kind of arrested is used for arresting the leakages. Then there is a sample architecture layout for that I have for a experimental purpose. I have to attach two architectural drawings. I just, before showing the layout, I just want to the walk through the layout. H room is here, so we have to see how behind the H room there is a staircase. We have also shaft is there, so we cannot run the duct through this wall. So how, since the shaft is here, we cannot run the duct. Why? Because the shaft is dedicated for a pipe or electrical panels, sorry, electrical cables or any process pipe, anything. So we can see other side, can we run the duct on this side. This side there is a service lift, so there is no other way, we have to run the duct on this side. So such a way that we have to study the architectural layout and design ducting systems. Okay, it is a typical IT building. It is a open workstation. Okay, there is a number of cabins. IT, sorry, meeting room. 6P is called the 6 packs. 5 packs. P is called the packs. 5-person sitting room, that is called the 5 packs. 6-person sitting room is called the 6 packs. Okay, recreation room, and it is like a regular IT building. Okay, so we have to plan a design how we can supply a air into the room. Before that, as explained by Ms. Vishali, heat, we need to do a proper heat load calculation. As explained by Mr. Regu, we need to do a proper equipment selection. Okay, based on the continuation, we are here. So we have done our heat load calculation, we done our equipment selection, everything. So now we are going to do a ducting calculation. So we have to choose the duct routings. We can run a duct on the above the people. No, we have to run in if we run a duct above the people, what will happen? No, we cannot access, or we cannot do maintenance in a we cannot there will be a working going on in a day-to-day regular basis. We cannot disturb the people, or we cannot just get into the table and disturb the people, because the production will get affected. The duct routing and design, everything should be designed by considering the maintenance aspect, and proper routing, and velocity, and equal friction method, and positioning of there will be a clashing of if we can run a duct here. Already there is a number of pipe cable trays there, so we cannot run a pipe duct here. So there is no other way we can take a offset of small portion. We can take offset, or make consider such a duct design in a worst case. There is no other case we can do. We can take a duct by that way only. But how we can avoid? There is a in the drawing, the project is awarded for multiple vendors, like a HVAC vendor, sorry, HVAC consultant, then MEP, sorry, firefighting consultant, and electrical consultant. Everyone will be start working. No, then we have to be very dedicated, and we have to deliver our project in a very short time period. So that we have to take our place, we have to occupy our place. Okay, that is a way we can do a proper design. In a worst case, we can say no, this way I cannot take a duct. You just reroute your pipe. Somebody will accept, somebody will not accept. The argument, conflicts will be created. So avoid such cases. As if you are receiving a drawing, you do your job very quick, very short time period. That is our job. Okay, in such a way that it is not only depends on design, it is depends on the very short time period. That then only we will get a place to run the duct. So as I said earlier, this is a H room. We are running the duct to this pathway, and based on the maintenance aspect, we are running the duct in corridor and walkways. Okay, you can ask me why you are serving the duct on this bottom. This is called peripheral area. Okay, what is peripheral area? It is like a generally IT building will be coming with or installed with the glazings. Okay, full height glazing, off height glazing. General max 90% of IT building will be constructed with glazings only. In such cases, the heat directly will enter into the space. Okay, if you are running the duct inside the corridor or mid of the space, the air will be the person sitting in the edge, okay, near the window. He will not he will not sense the cooling effect. Okay, he will always feel the hot, and he will not be comfort. And what will happen if he is not comfort? What will happen if I'm sitting in if I'm doing a work in terrace by noon? What will happen? I will getting hot, and I will get hurt. My mind will not work. Okay, if I'm in an office under conditioned space, I will be feel very comfort. I can work in an effective way. So everything is everything is based on the production. Okay, the production is called nothing but the factory is producing a tire, the factory is producing a material. That is not the production. That is production is called even a IT building. The person working, the person and the company is spending lakh for this person. Okay, if he not able to deliver a project at right time, okay, what will be the loss? What the loss will be the company. Okay, so avoid such cases, we have to design our system in effective manner. So these are the things we have to keep in mind while we are designing. See, these are the very important points. Then another building, this is a rectangular building, this is a some zigzag building for another sample. So H room is there, there is no space for outdoor unit, so we have created a partition inside the H room. We have kept our outdoor unit on outside, again about next of the partition, and we have kept our HU inside the room. Okay, then we are serving the duct like without disturbing the we are serving the duct in the corridor and without affecting the occupants area. Okay, so we have seen how to design a duct, what are the types of duct available, everything. As of now, we are in the position, we know how to design a duct. Okay, now we have designed the duct. Next, what we have to do, we have to classify duct 0 to 750 mm. Either it can be a width or a height. Okay, the height may be 100 mm, but the width is 750 mm. That is classified, comes under 25 cages. Well, okay, the 25 cage it is a unit. The cage is converted into mm. It will be 0.63 mm. Okay, then for a 750 mm duct, we need to provide a supports for 2.4 to 3 mm 3-meter distance. Okay, the distance, the we have to give a anchor fasteners and wire hanger support. We can give any supports, but that support distance should be minimum up 2.4, the maximum of 3. Okay, what will happen, we can provide even for 100 mm. Okay, what is the use, but our requirement is for 2.4. Okay, we cannot give a less than a very short we can give a very short distance, no, 1 meter, 1 meter. The supporting cost will be getting increased. Then definitely client will raise a question, why you have a design a wonderful job, but you made us to lost our profit in stupid supports. So the support is also matter. Okay, you have to select a duct size based on this criteria, and so provide the supports based on this distance. This is available in SMACNA and ISHRE handbook. Then support rod, what will be the support rod for a 750 mm duct? The support rod can be a 6 mm. The higher size duct we cannot provide the same 6 mm because the load will not be load will not be uh, accepted. So for huge sizes, we need to provide a based on the design. We how the anchor fastener or rod directly cannot be poured into the duct. The duct is settled or placed on the angle supports. Okay, the angle support is maybe a MS angle, L angle. L angle is like uh, it is nothing but L shape structural rod. L shape of either both side of 25 mm length with the thickness of 3 mm. Hope you can understand the and the same it is applicable for all the sizes. Please take a screenshot for the screenshot. It will be useful for when you're designing or doing calculation. Hope everyone took a screenshot of this. So I'm moving with the next slide. Duct area calculation. This is a basic area calculation for rectangular duct, taper duct. Rectangular duct, we need to calculate the four side, 2 width and 2 height. Either we can width plus height, or width plus height into 2 into length. We can describe that in such a way. Then the taper width plus height. There, if it is a taper, there will be a 2 height and 2 width. So we have to calculate the whole thing and multiply the length. Okay, we seen it is generally will be 300 or 450 or 600, depends. Okay, then elbow will be based on designed based on the inside radius, 150 radius, and This is the formula. Then offset we have to work width plus height into 2 into length plus offset in the sense uh, this is offset length into offset in the sense the center point of inlet to the center point at outlet. That is the difference. Maybe on the 100 to 200 that will be like okay, that we have to consider. So length plus offset. Insulation thickness, it is same like a straight duct insulation, but this is a formula you have to apply for acoustic insulation. This is you assume that this is a insulated duct. Okay, how you can arrive the quantity of the insulation. For a duct we can take in a very easy manner, but insulation it is little complicated. We have to use our brain, which you have to apply our knowledge, basic thing, common sense, everything. Okay, when width plus height into 2, that means the whole peripheral area minus if it is acoustic it will become inside the duct. So we have to, there is a 4 thickness, 1 thickness, 2 thickness, there is a 4 side, so we have to multiply for 4 side, and we have to minus for that from the whole peripheral area. Then we have a one plain sheet. Okay, that sheet is we have to ask the insulation sheet by mentioning the thickness, 15 thickness or 9 thickness. Okay, then only we will get a proper and that basis only we have calculated the area. We have calculated for 9 thickness, and we have asking for 15 thickness, means 15 thickness area will be high, because it is depends on the area, sorry, thickness. Okay, you have to be focused on doing every small work. Then it is if it is for a thermal insulation, the thermal insulation will come outside of the duct, so we can add plus shoe duct formula. Shoe is collar piece. Then dummy is the duct is closed, in portion is closed, is called the dummy duct or end cap. Then down duct is calculated based on the peripheral into length, 2 pi r into length. This is a very basics, pi r square, 2 pi r width into length. We have studied from even LKG, UKG, first standard. We are studying from very basic shapes, round shape, round, cubic, rectangular. From that it is arriving. So yeah, you have to just focus on you have to apply for your common sense. Then tangent duct, oval duct, this is the formula. Just to take a screenshot and try to apply for your working purpose. Time is getting too late. Then BOQ quantity, how we can take a quantity. Okay, we have done design a duct, we have mentioned we have a capture, we have we have designed a duct, we have captured the acoustic insulation for 3 meter, and then rest of the duct is captured with thermal insulation. Okay, this is a sample duct routing. When we are doing a duct design AutoCAD drawing, you can use some colors for legend. Supplier duct, you can use some blue color for supplier duct, red color for return air duct, green color for fresh air duct, again red color for exhaust air duct. So this are the general color codes for designing ducts. Then this is called hatch. Okay, in AutoCAD there is an option called hatch. Maybe some if you are well known in AutoCAD, you may know what is hatch. So we are representing or specify the acoustic insulation by this kind of hatch. This is a common language. This is a drawing is a engineering language. Okay, I may know only Tamil. Okay, but you may know only English or Hindi. How I can communicate with the drawing? There is a standard codes. Okay, that so in drawing you should use only capital letters. Okay, you should not use a cubic meter per hour in a small letter. You should use letters in a CMH. Okay, there is a cubic meter per hour. You have to mention bottom of that. There is so many things. Okay, this is a blowdown of sample layout. I have taken quantity for every positions. Like there is a riser from the duct. Sorry, AHU H top to duct bottom, there's a riser. Then one elbow will be there, that is number 2. Then straight duct, that is 3. Then again one elbow, that is 4. Again one straight duct, that is 5. Then 6 is I have mentioned for there is a motor volume control damper. Then again I mentioned 7 as acoustic insulation, and 8 I mentioned as a thermal insulation. 9 is grill. Okay, these are the quantities available. These are the device equipments or duct and ducting accessories available in the drawing. We need to take this quantity and develop a BOQ, that is bill of quantity. Then we have to float for float the tender. As a consultant, as a contractor, you have to take a quantity, then only you can procure the material from the duct manufacturers or air tunnel manufacturers, everything. We cannot simply develop a drawing and my part is over. That is not. You have to you have to design a duct in all the aspect, and you have to take a quantity, okay, in such a way that everything is covered. Then how we can take a quantity? There is, I have mentioned the numbers, no tag numbers. By using the tag numbers, tag number 1 is straight duct, tag number 2 is elbow, tag number 3 is straight elbow, 4 is 90-degree elbow, 5 is straight elbow. Duct size is width height is based on 1388 cross 350. I have taken from some project for some understanding purpose, but I said earlier we have to round off the value. 1388 means we have to round off the value as 1400. Okay, the duct width is crossing more than 1350, so it is coming under 22 gauge. Okay, what is 22 gauge? 752 1500 is coming under 22 gauge. Okay, so I have calculated the area on 22 gauge. You have to calculate the 90-degree elbow, end cap, everything will be there based on the above based on this calculation. And then volume control damper. Volume control damper we can give in width height into quantity. We'll get the in area. It is in mm. You have to convert into meter. So be careful. The same is applicable for grill. Then for acoustic insulation, thermal insulation, we actually we have a automated. We have a developed Excel sheet for easy calculation purpose. I cannot share you because why? Because you have to do manually. Then only you will become a very you can gain the knowledge in a effective manner. You know what is happening behind the system, behind the tool. You should know. When you can know, only you are applying the basic formulas. Then what are the do's and don'ts of duct designing? You cannot take a immediate branch on the HU, like a bottom or a top, even it is a fan, exhaust fan. You should not take an immediate branch. You should take at least 3 dia of the. You should take a 3 times dia of the length. You should consider for a better airflow. Then if there is a beam, you should not take a offsets like this. If there is you just consider beam, you should not take a offset like this. You have to keep a machine on after the beam or before the beam. You should have maintained that 3D length and then take offset. There is no issue. If this is a top view, this is the offset, this is the side view, you have to take a straight duct only. Then you have to, of course, you are it is mandatory to give us shoe pieces, then only the air will go in a smooth way. If we are not giving a shoe pieces, no, the air will it will confuse it. The entire air will be filled here, and only the filled air will be going inside the branches.
Siraj?
Yes, sir.
Siraj, I think 3:30 the next session will start. I think you are going another 30 minutes you are taken. So next session will start at 3:30. Okay, please adjust with yourself. Okay.
Not an issue, sir. It is over. This is the last time.
Okay. Okay.
Again, we have to. We cannot take a diffuser or grill or simply end of the duct. We have to give some at least 6 inches space from the last grill. Then only the air will go and fill the spaces, and the continuous flow will be like this. If it is a it is called a mitred elbow. The air will not be in a smooth position. It will be like the turbulent. So it should not be uh, down and loose. That's it. If you have any queries, quickly you can raise. I try to address in a short time.
Participants, if you have any questions, you can put it in the chat, or you can unmute yourself and you can ask questions. Okay.
Actually, it is a very main chapter. With for a heat load calculation, you can arrive from the you can MCP delta T easily get the heat load from the wall. You can easily arrive the load from the roof. You can easily arrive the load from the internal load, and you can easily select the equipment. But it is duct sizing is a big uh, role of HVAC engineers. So you should be clear with this chapter. Then only you can do a drawing and everything. Also, I would like to highlight one point. Winning is not a matter. Uh, the knowledge gaining is the matter, as said by the professors, my seniors. So try to develop your knowledge by gaining knowledge. The more knowledge the gaining, you will be a well wanted person in the society. So if you have any queries, duct loading, there's a call software clause. Software is called duct sizer, Macway. I will share the link on chat box.
Okay. I think it was a very good presentation by Mr. Sirajuddin. He has gone into deep into that the design of HVAC ducting system. So right from the basics to the advanced level, and it was a very useful presentation. Thank you, Mr. Sirajuddin, for spending your valuable time. I think today your festival, you are sacrificed your time for the sake of participants. Thank you very much.
My pleasure, sir. Thank you, sir. Thank you very much, sir. Thank you, everyone. Have a nice day. I'm leaving. I have another meeting, sir. I'm leaving, sir. Is it not a
Yes, sir. Yes,
problem?
no problem. We will inform you, sir. Yeah,
Okay, sir. Okay, sir. Thank you. Thank you very much, sir. Thank you, everyone. Thank you all. Have a nice day. Bye.
Thank you. Vishnu,
Sir, yes, sir.
shall we start the next presentation? Are you?
Yes, yes, sir. Yes, sir.
Yeah. Okay. You ask the participants whether we need a break or we can start with immediately.
Sir, Rigo, yes, sir. Sir, from
Yes, sir.
student point of view, we will have 10 minutes break, sir. Definitely, for sure, sir.
5 minutes, sir.
We will have 10 minutes break for us.
Okay. Okay.
Okay, sir. We can manage the thing, but let them take 10 minutes break. Let them go to any. Let them do because it will be very afternoon session. It's going to be tougher. So we will connect at 3:40, sir. Maybe if anybody wants any points to be discussed, you can unmute, or if anybody wants to discuss something, you can. I'm available now, but the real session is going to start by another at 3:40.
Okay, sir. Fine, sir. Fine.
Thank you. Thank you.
Mr. Siraj, I think you are presenting your screen. Okay, thank you.
Sorry.
No, your personal messages, it is being presented.
Yeah,
here.
yeah, yeah.
Okay.
I see.